Alright, let's take a look at question 19. In this one, we'll be assessed on how to generate a function for geometric sequences. Okay. Question 19 reads, which function could be used to represent the sequence 8, 20, 50, 125, 312.5, and on and on and on, given that a1 is equal to 8. a1 is the first term, okay? Alright, before we get started, let's go over the formulas for the arithmetic and geometric series functions. Alright, so let's write this down. Formulas. For the geometric series, we can write this using a recursive definition or just a function. In this case, we're using a function. So a of n, a as a function of n, is normally given by the common ratio multiplied by the term before a, the term before an minus 1. Okay? So if you multiply a common ratio by a term, that gives you the next term. Alright? So the term before an is an minus 1. Now, how about an arithmetic function scenario? Arithmetic. So for arithmetic, an is basically the term, the common difference plus the term before. Alright? So you see the difference here? For geometric, you're multiplying by r, which is known as the common ratio. For arithmetic, you are adding d, which is known as the common difference. Alright? So that's the difference here. So another thing to keep in mind is that the common ratio for geometric sequences is a term divided by the term before it. So let's just use concrete examples. Common ratio is a2, a term divided by the term before it, a over a1, or a3 over a2, or an divided by an minus 1. Alright? And then for the common difference, it's basically the term minus the term before it. Okay, a2 minus a1, or a3 minus a2, or an minus an minus 1. Alright? So that's that. Now let's look at what we have here. The question is this sequence geometric or is it an arithmetic sequence? Alright, so all we just have to do is see if we have a common ratio or a common difference, then we'll know for certainty if it's arithmetic or not, or geometric. Alright, so we're going to start by testing it to see if it's arithmetic. So arithmetic test. We're looking for a common difference. Alright, so first one, D1, difference 1, we're going to subtract the first two, 20 minus 8. What is 20 minus 8? That's 12. Looking good. Alright, so difference 2, we're going to take the next two terms, 50 minus 8. No, sorry, 50 minus 20. 50 minus 20 is 30. Uh-oh. Ladies and gentlemen, the difference are not common. Since the difference are not common, this sequence has failed the arithmetic sequence test. Okay, so this sequence is not arithmetic for sure. It's not arithmetic. Alright, so we automatically know that it should be geometric, but let's not just make any assumptions. Let's test it and see if it's geometric. Alright, so for arithmetic test, we're subtracting. Guess what we are going to do for the geometric? We're going to be dividing. Okay, alright, let's do it. Alright, so let's look for the common ratios to see if they are common. Find the ratios to see if they're common. So for the first ratio, R1, we're going to divide 20 by 8. You could do that with your calculator. So 20 divided by 8, you could divide by 4. So you have 5 over 2, which is 2.5. And then ratio 2, divide 50 by 20. 50 divided by 20. That's another 2.5. Ladies and gentlemen, it looks like we have a winner. Let's just do one more just to make sure, okay? 125 divided by 50. All right, let's use our calculator to check this out. So what is 125 divided by 50? 2.5. So what does this tell us? It tells us that this sequence is geometric because we're multiplying by the same constant every time. Multiply by 2.5 and multiply by 2. So when you multiply by the same number every single time, your sequence is geometric. Okay? Alright, so we're going to be using this formula right here to solve the problem. All we need is the common ratio. An and an minus a sub n minus 1 are variables, so we'll leave those alone. Oh, wait a minute. We know what a1 is, right? Let's see, we're going to be using it here. No, we don't need a1. Okay, so for the geometric series formula, let's just rewrite the formula here so we can have a guide. We're using a sub n. A term is equal to the common ratio multiplied by the term before that term. Alright, we know from our computation here to the left that the common ratio is 2.5. So all we're going to do is take 2.5 and plug it into the common ratio spot in the formula, and then we're going to get an is equal to 2.5 multiplied by a sub n minus 1. The answer to question number 19 is option number 2.